Alrighty. Alrighty, how's everybody doing? All good. Perfect. All right, so I guess we're going to start in like 2 minutes. Let's just wait for everybody. All right. All right, so while we're waiting for everybody, how's everybody's midterm? I mean midterms, not midterm, sorry. $590, yeah. Oh my goodness, yeah. $590 was terrible. Yeah. I don't want to get any reminders of it. Oh, hey, Jenny. My C++ senpai. All right. Control systems. Okay. Oh, I think that's EC. Yeah. Haven't taken that course. Dropped out. All right. I guess, okay. So let's get started. So I hope everybody's doing good. Today's workshop is Introduction to Modern C++. So yeah, let's dive right in. So first thing, a little bit of my name is Ahmad. I'm a C++ enthusiast. Like, if anybody here knows me, I am just I live, breathe, and sleep C++. I love compilers, language design, and modern C++. Other than like tech or like CS related stuff, I love corgis. I love coffee. If you guys have, you guys want to talk about coffee, brewing methods, and things like that, let me know. Try to get, I try to experiment with a lot of exotic beans and a lot of interesting stuff, and I love Star Trek. But yeah, so here's some stuff to reach me if you guys want to hit me up anytime. Yes, this will be posted. Anytime you can hit me up on Discord through DMs, and if you want to chat about something, anything, I'm always open. And then there's my GitHub and Twitter and blog if you guys want to follow that. But yeah, so let me get started with that. So a quick outline of the workshop. We have a couple of parts. So part one, why modern C++, types and variables. And then we're going to talk about some containers like vectors and array. And we're going to do some control flow like if statements, loops, and such things. And we're going to be talking about objects, namespaces, enums, and also I added a bit on there. We're going to be solving some leak code problems, so we can actually get a feel of C++, but that's going to be at the end. Part two, more things will be added for sure, but at the moment we're probably going to be discussing templates, memory management, and constant expressions. But yeah. I'm 100% sure there's no way, if you program and have been online, like online for the past, let's say, the past 5 years, you probably have seen this meme right here. You learn C++ in one video. So you have like, this is the meme that you see, the first two boxes. But I found this meme was really funny, and this is what the workshop is about. It's learn C++ times 30,000. So we're going to speed through it, and I'm going to discuss why. So here's the prerequisites. I assume that you folks know control statements, so if statements, loops, functions, subroutines. object programming, so object-oriented programming. And the reason why I assume that is because everybody here, most likely, because first years and second years would have taken CPS 109 and some of 209 for CS, and for our people in comp eng or like in engineering in general, they have taken CPS 125, and then for the second years they would have taken Java in 328, if I'm correct. But yeah, so assuming that everybody should know this, unless maybe if you're an Eng first year, you might not know some object-oriented stuff, but that's fine. I'll walk through it. Don't worry about it. So what you need right now is a text editor and a C++ compiler. For now, because getting that set up on your machine might be a bit tedious and a bit annoying to set up like at this moment. So you can use REPL.it just to run some of the code examples and things like that. I'll be posting a link to all the code examples. It's on a repository, and even this, like these slides, if you want them to like have them with you, because it's a quick crash course on C++. So let's get started. What? Why? Modern C++? What? All right. So modern C++ is a general purpose language. That means it's not a domain specific language like, let's say, R or how do I? So a couple of languages that are domain specific, or for example, MATLAB that are scientific computing or like computation specific. This is used everywhere. It's multi-paradigm. That means it supports a lot of paradigms like procedural, object-oriented, generic, functional, and a bunch more. And it features a lot of cool features, and that's why I love C++. It features object-oriented programming, template meta programming, compile time, like a lot of cool compile time stuff. And to be honest with you, that's one of my favorite things in C++. And C++, one thing to understand about C++, it's not owned by one entity. What that means is, for example, Python, when there's a new Python that comes out, it comes with a Python interpreter. But C++ doesn't work like that. It has a committee which is standardized by ISO, so International Standardization Organization. And then see the link right there that I posted. So what that means is the C++ doesn't have a standard compiler that comes with it. There's different implementations like GCC. You probably have heard of GCC if you've done 393 and 125. You've probably heard about also, we have GCC, there's Clang and MSVC and all these other compilers. So yeah, so there's different implementations, but they all adhere to the standard or supposed to adhere to standard. And then there's a wide range of standard library facilities. You can check out CPP reference. This link is going to be like the Bible of C++ to you. I have it bookmarked. It has everything that you need about C++ and like a pretty readable documentation, and I use it daily. And I recommend you people, if you want to like bookmark it, you should. But yeah, so that has a lot of library facilities, and we'll go into that a bit later on, maybe at the end of part one and in the next workshop. But yeah, so why C++? It's used everywhere in AI, machine learning. So TensorFlow is written in C++. Data science, GPU programming, like have you? I don't know if you folks heard about CUDA. Or a lot of GPU programming stuff, video games, graphics like Vulkan, OpenGL, cloud. C++ is used in cloud everywhere. And the reason why C++ is used in all of these fields is because it allows for reusable and clean code, yet it's efficient. Again, if everybody here checks out like all these benchmarks on C++, they'll be like, wow, it's surprising. You can write faster C++ code than C? What? Like, people would be surprised when they first hear that. But yeah, trust me. It's a beautiful language. But yeah, so I have a quote up there by Bjarne, who is the creator of C++. The standard library saves programmers from having to reinvent the wheel. Other than that, it has fast runtime and it's improving. That's what's wonderful about it. So you see a lot of people mention, and sometimes I mention that modern C++, and I've mentioned in the description of this workshop that I'll be doing modern C++. But what is modern C++? Well, if you remember what I referred to before about the standardization process, modern C++ refers to everything C++ 11 that was standardized, like that was released as the C++ 11. and above. So C++ 11, C++ 14, 17, and 20. And then we have 23 coming up soon in 2023, hopefully. So yeah, so the first time C++ was standardized was in C++ 98, so 1998. And this is a wonderful graphic that shows you all the features that have been added to C++. So in 98, templates were added, algorithms, strings, IO streams, and all of these things. Like you can just check these all out. I'll be posting the slides obviously after this, so you can check out the slides and go through them. But all of these were added, and C++. A lot of people call it the the old new language, because it's getting a new standard every 3-ish years. I think, yeah, it's 3 years now. So yeah, so every 3 years, and it's improving and improving further and further. But yeah. So one thing that I wanted to discuss before getting started, C++ core guidelines. I know this is a bit later on, and you folks will be using it a bit later, but this will teach you how to use C++ effectively. It has a lot of tried and used methods for reusability, safety, and longevity, so your code can last long and be more maintainable. Check this link out. This won't be used in the beginning steps of you learning C++, but I wanted to mention it because I wish I knew about C++ core guidelines in the first, I guess, book or course that I've taken on C++, because trust me, it's very useful. Because a lot of questions, oh, should I do this? Like, you have two options of doing something. You could check it out in the core guidelines, and most likely there's an answer about that. But yeah, so let's start with some C++. So types and variables. So basics. C++ is a statically typed language. That means types are determined at compile time, not like Python, JavaScript, and everything. And each variable must have a type. Let me pause for a second. So there's a question. What is the advantage of C++ over C? I've heard memory management, and why is it important? So C++ allows you to write more generic and cleaner code because it's modern, right? And some people prefer C because of the domain that they're using. But I've read this thing once, which Bjarne mentioned, and what he mentioned was the reason why people don't use C++ in their domain is specifically because there's no C++ compiler available, which right now it's not something that is like holds true. So everything that you're gonna have a C++ compiler. But yeah, so the reason why C++ is used over C, because it allows you to write more expressive code. Um, for example, C doesn't even have strings, right? It doesn't have dynamic data structures. It's all right. So yeah, so I went off for some reason. My internet went down. All right. So I guess I'll I'm not sure where I stopped, so I'll continue on, and if you guys have any questions, just let me know. So yeah, so in C++, there's a bunch of primitive types. So we have integers, so which are short, int, long, and we have unsigned integers like unsigned int. Each one have their specific sizes, such as oh yeah, so last thing we heard, C doesn't have dynamic data structures. Yeah, so C does not have dynamic data structures, and it doesn't have any generic algorithms. And you, I'll show you guys a bit more what I mean by that when we get through the examples. And in the examples, we'll show you that the C standard library is tiny compared to C++. But yeah, so I'll bite size them. And then we have real numbers, which are float and double. And then we have characters like char, like characters and unsigned characters. Give me 1 second. I think 1 moment. All right. Just checking with my internet. I'm not sure why it went off. All right. So, and then we have Boolean, which is a bool. But yeah, other than that, actually let's go back here. I just want to have my I'm going to put my phone on data just so I can see if it goes down. All right, perfect. So, yeah. Other than that, we have a type called auto, and it's not really a type in specific, but it's just asking the compiler to determine the type for you. But that type determination occurs during runtime. That means you can't really change that type, and it doesn't occur during it occurs during compile time. It doesn't occur during runtime. But it's mostly used for ugly types. There's some long types and things like that auto is used, but the standard like the core guidelines recommend you to use auto as much as you can in places that where they could be used. And I think in auto C++11 it wasn't that usable, but now with the recent C++ standards it's actually even usable during in functions, their arguments and their return types. And I'll show you more about that a bit later. So here's a quick example. I'm going to run through this really quick. So first thing, what we need to do is it's same thing as importing in Python. We need to import IO stream, which is the input and output, and then it has C++ has an you could say like an entry point, or this is where the program first starts. Yeah. So and then yeah. So then we have the main function, which this is where everything executes. So let me run through this real quick. So we have an integer a, and we're going to assign the integer to 1, 2, 3. And then we have an integer b, and then we're going to assign that to 123.923, and then we're going to print them out. I'm not going to go through the printing syntax. It's not that important in C++, so let's focus on what it's printing. I'll go through the syntax a bit later. So we have a is equal to 1, 2, 3, and b is equal to 1, 2, 3. That happens because an integer is not like when we define this as an int, declare this as an int, the decimal places get dropped, so it doesn't get stored inside the integer. And then we have a double here, which is a real number, and inside that double we have 255.123. And then we have a Boolean, which is D, and we're going to set that to true. And we have a character E, and we're going to set that to E. And then what we're going to be doing here is we're just going to print it out. As you can see, the doubles, so C gets printed out as is. D gets printed out as 1 because in C and C++, 1 is true and 0 is false. And this is true in mostly all the programming languages, except for Bash. But yeah, and then E gets printed out as E, the character that we set. And then here's a quick example of auto. Auto, for example, we have auto A equals to 1, 1, 2, 3. And that is deduced by the compiler at compile time. Note that happens at compile time, not during runtime. And it's deduced to an integer. And then we have auto B, 123.123, and that is deduced to a floating point number, be it a float or a double precision floating point number, so a double. And then another example here, flag equals to true, and that is also deduced as a Boolean, same with the character, as you can see here. But yeah, so the whole point of auto is just to let the compiler decide for you what type the variable is. And that is pretty much it with auto. And then we're going to be talking about strings. So strings are not a fundamental type um, or a primitive. It's not a fundamental type or a primitive in any language. So it's included on all their standard libraries. So it's included in string in C++. And see the link that I posted here for more facilities what we could use strings on. But let's jump into the syntax real quick. So when we need to print, obviously, we need to include IOStream. And then when we need to use strings, we need to include string. And then inside the main function, I have so stud, uh, 2 colons, and that means that's the namespace of, so that's the standard library. That's why we always have stud in here. And then string name is equal to Ahmad. And then we're going to print that out. And when we print that out, we get my name. And then same thing, I can do name.at1, and that's going to print the second character right here. And then I could also append some things. You could see the link that I posted right there. A lot of operations you could do on strings are listed there. Well, all of them actually. But yeah. So you can append, and I'm going to append my last name, and then my first name and last name gets printed. So let's discuss a bit more about containers. So containers are included in the standard library. So these are data structures. They're called containers in C++. So they work with the standard library algorithms beautifully. So for example, in Java, every single data structure has its own implementation of every single algorithm inside of it. Where in C++, it's pretty much a generic data structure with with generic algorithms that have something that allows them to work with together, which we'll be discussing about a bit later, which are called iterators. So containers are self-managed. That means when you use containers, memory is managed for you. Everything is done for you. You don't need to worry about nothing. And then you have so there's a rule, and I think it's on the core guidelines, but I'm not sure if it's on the core guidelines actually. But somewhere I heard that std vector and std array are your friends, and you should use them almost always. And I remember there was one person that mentioned, and I'm trying to remember their name, but what they mentioned was if you're not using std vector or std array, you need to write a comment why. But yeah. Let's discuss a bit more about vector now. So check out this link, CPP reference right here. It's going to tell you about all the containers included. We're just going to be discussing about 2 containers, and they're the most used containers. So we're going to be discussing about vectors. Vectors are a dynamic array. So like lists in Python, array lists in Java, and I guess, yeah. So trying to remember any other languages, but yeah, anyways. So then so they're random access. That means that they're not implemented as a linked list. So for example, I don't know if anybody here has done elixirs for 506. Lists are implemented in a linked list. So that means that if you want to access the 6th element or whatever element, it's O of n. What random access means is it's a constant time access for each of the elements. And then elements are stored in consecutive memory. So they're not a linked list. They're stored in memory consecutively. And to use it, like how we included string, we're going to include vector, and see the CPP reference for that. It has all the things that you could do on vector. So here's a quick example. So this is how we initialize a vector. And no, I know I'm going, if I'm going too fast, or if you need any syntax help, just let me know. The reason why I'm going a bit faster is because, 1 second. Yeah, is because I assume that like we just know a bit of Java and C, everybody here, hopefully. So I guess syntax should be a bit familiar except for a couple of things. But yeah, so here we have std vector, and then it's defined as how we do it in a string. We do std vector, and we have those I don't know what you call them, like those angle brackets. Yeah, I guess that's what you can call them, those angle brackets, and we put the type of what is inside the container. In C++, vectors are not like in Python. They need to have the same type in them. So right here, we're putting an integer as a type. And then here's a quick sample. So we're going to store inside sample 1, 2, 3, 4, 5. And then here's a quick thing we can use here. I'm just here, the comment here just showing what is stored inside sample, just so we can visualize a bit more. So I'm going to push back. That means append. So I'm going to be appending 6 onto the vector. So here I appended 6. So 1, 2, 3, 4, 5, 6. And then I'm going to be appending, I'm going to set like sample at 1. So when I do at 1, it's going to give me the second position. So the first position actually. And then if I want to set that first position to something else, I could do sample at 1 is equal to -9. And that is going to do the following right here. And then there's a mistake actually here. I just noticed this is not supposed to be a -1. This is supposed to be a 1. I don't know why I put a negative, but yeah. So we can actually we can do auto a is equal to sample at 1, and then a will be -9, and the type of that will be int, because obviously the compiler, when you compile it, the compiler will know for a fact that a is an integer because sample holds elements of integers. But yeah, let's, I guess, go into arrays. So arrays are static arrays. They're like, so there's something called raw arrays in C++, which are called arrays. And so let's actually not confuse this with a couple of terminology. So in C++, there's something called arrays. Arrays are provided by the standard library. And in C++, there's also something called raw arrays. Raw arrays are what C programmers call arrays, but it is recommended to never ever use arrays, like raw arrays, in your code. That's why I'm not going to be discussing them here. I'm going to be discussing arrays. So like the standard library arrays or the C++ arrays. So they're static arrays. They can never grow. So they're like a vector, almost like a vector exactly, but they can never grow. They have random access like a vector. There's no dynamic memory allocation. So if you have an array, you can't change its size or append to it. And then you can include array, same thing how we included strings and vectors. We can include, just do pound include array. And the users is the following. It would be std array, and then we'd put the type and the size of that array. And then you could see the link right here that I provided. Has all the things that you could do on arrays. But yeah. So here's a quick example. Std array, angle brackets, int, comma, 3. So right here, I'm saying that sample holds integers, and it holds 3 integers exactly. And then we initialize it the same way that we initialized a vector in C++, in like the past couple of slides. We're gonna, because it's gonna be holding 3 integers. We're gonna put 1, 2, 3, and then sample will obviously hold, as you can see right here, 1, 2, 3. And then we can also call sample at 1, and then we get 2. And we could call sample at 0 is equal to 9 and 99, and then we set the 0th position of sample to 99. Yeah, but if there's any questions, please let me know in the chat. I'm still going to be walking through this because this is very basic syntax. So let me know if you're a bit confused about something, and I can go back. So let's go into control flow. Control flow, so if statements. If statements are like any other language, like Java, like Python, like any other language that you have used that has if statements. Here's a quick example. If, and you need brackets here, not like Python, a is equal to 1, then you execute what is inside here. Else if b is equal to 2, then b is equal to 2. And then also that means that if, because it's an else here, so that means that b is equal to 2 and a is not equal to 1. And then here, if we go to the else block, then that means both conditions are false. It's just like your basic if statement, and it's almost the same syntax and same usability. And then you have raw loops. So these are raw loops, and they look exactly like Java, but I don't think Java has auto, does it? I'm not too sure. Correct me if I'm wrong. But yeah, so this is a raw loop, and what that means is the old style, you could say, type of loop. And I'll show you what the, I guess, quote unquote new loop, or like the proper loop to use when you can use it. But yeah, so it's as simple as your Java loop. So for auto I is equal to 0, while I is less than 9, I plus plus, and then you do whatever you want inside here. So I'm going to print out from 0 to 8, and you can see here it prints it out. Another example would be using this on a vector. So let's print out the contents of a vector. So we do for auto I is equal to 0. I is less than sample.size. So dot size gets me the length of the, so it's like len in Python. And then I do I++. And then I++, and then I just print out sample at I, and that prints out the whole vector for me. And yeah, so we'll move on from loops. And then we have range for loops. So they're more expressive and they're added for safety because let's say right here by accident, I don't, here actually, can I go back? Give me one sec. Yeah. So, oh, whoops. Yeah. So let me go back to raw loops real quick. So right here, if by accident I don't put the correct size of the vector, what will happen is I might actually get an out of bound error, and that will raise an exception and it will stop my program. But yeah, so that's one thing to note is in raw loops should never be used for containers or data structures. You should always use range loops because you have the added safety. So they're more expressive and they have an added safety. They're used for containers, including the standard library or anything with iterators. What that means is iterators, like I said, remember how I mentioned that C++ is pretty generic. So we have containers, which are generic, and then we have generic algorithms. And both of these interact using something, and that thing are iterators. So if you create a data structure yourself and you implement iterators for that data structure, you are able to actually use all the standard library algorithms, everything like the range for loops and everything. But yeah, so let's walk through the examples right here. So I have sample, a vector of integers 1 to 6, and I'm just going to print them out. And the syntax is as simple as for int I, and then a colon right here, sample. And then I would be printing I, and I would be the element. So I wouldn't be doing sample dot at I. I would be the element itself, and then I'm printing out the element. But the problem with that is the following. So every time I am going through the loop, I am initializing a whole new variable like in memory, and that whole new variable every time, every single loop iteration, I'm creating a new variable and putting inside that variable the element itself. So copying that element, and that is pretty expensive. C++ has a solution for that, and it's not pointers. For the people that have done C, uh, pointers are not encouraged to be used. So raw C style pointers are not meant to be used in C++. So there's something called references. So what that means, it's a reference to the memory of that element. So right here, what we could do is we do auto that ampersand I. Let's forget about the constant right now and explain why there's a constant here. But auto ampersand I sample, and then in that case, I is just a reference of the element. So that element isn't copied into I like here, and then printed, where this is just a reference to, it's just, let's say, point. You could think about it like it points to 1 and it points to 2 every single iteration. And then the constant here, the reason why you should always put constants in your code, what that means is because right here I'm only printing the code. Because it's a reference, I can actually change the memory location. So I can do I is equal, let's say we're going through the first one, and by accident I put I is equal to 0, then I zero out the whole thing. But if I have a constant here, it doesn't let me. So just an added safety where it's not mutable, so you can make sure that you're not changing anything in a loop that is not meant to change anything. So that is the point of constant. And one of the books that I have right here, which is called C++ Best Practices, it recommends you to constant everything, and that every constant everything. And if it's not constant, you need to know. You need to explain why in your loop or function, because then you'd be changing something in there. But yeah, and then other than that, here's a quick example of what I mean by a reference. So if I have a simple loop, and I could use auto here because there's no need to use integer because the compiler would deduce it anyways. And if I do auto I colon sample and I change I to 1, nothing will happen because in that case, it's the variable, like each element is copied over to I, and we're just changing I. We're not changing the element itself because we don't have an ampersand here or a reference. So if I print that out, sample will have 1, 2, 3, 4, 5, 6. But here, if I do auto ampersand I, so I'm it's a reference, and I do I is equal to 1, then sample would be all ones, and we would have changed that. So that's one thing to note, and make sure one thing to always remember is always put your when things put everything constant unless you don't need it to be constant. But yeah, so other than that, we finished we finished range for loops, we finished raw loops, and if statements, and now let's actually jump into functions. So real quick, so obviously, assuming that everybody here knows functions and how to use them, we're just gonna go through the syntax real quick. So right here, we can put an integer. So int add int a, int b. So we're just doing it's the same exact thing as Java. So what we're doing is just returning a plus b, and we need a return statement with a semicolon right here. And note that there's the return type here, and these are the types of the arguments and the following. Or you have another way of writing it, and which is the way that I prefer. So I just put it here because you might see it in my code, where I put auto in the beginning, and I do add int a, int b, and then I put just an arrow. So that's called a trailing return type, and I put my type that I'm returning here, and just return a plus b. I use that just because it looks nicer, and I feel like it's more expressive. Personally, I love expressive code, so you'll see me write a lot of things that may seem weird, but um things that I like. I just think that they're more expressive, so that's a better form on writing it. Oh yeah, so this is the way that I write it. But here's the best form to write this, because like I said, right here, this is not being the arguments aren't being passed as references. So that means every time a whole new integer a is being created inside memory and a whole new integer b is being created inside memory, and a plus b are being copied over from wherever you're calling that into a and b into a new memory space. So now you used up more memory for no reason. So what you could do in that case, so this is the better form, you could actually include the ampersand here. So then you're capturing them by reference. So you're actually, the arguments are being passed by reference. What that means, like I said, is the a actually points to, like, is a reference to where whatever a was passed to, or NB. And then obviously in this case, you also need to include constant, because if by accident, because this is a reference, if you change a in here, a is permanently changed. Like, it's changed for, like, the arguments that you passed it are changed. So in that case, you need to include constant. And that's why I'm telling you, I'm telling everybody to include, put a constant everywhere you can. And this is because just to be sure, just in case somebody comes here after, like, let's say 5 years and changes the code here and by accident changes a to some other number, you don't want that to happen. So to make sure that the compiler tells the person you're not allowed to do that, you need to include a constant. So yeah, that's the best way to write, I guess, the better form of writing this add function. Other than that, here's a quick example of references. So I have a void function 1, and its int is getting passed in. So a is getting passed in just as a value, so passed by value. And then right here, fun2 is getting passed by reference. And right here, I'm incrementing a by 3 in both functions. So if I have an int x right here, and it's 9, and if I pass x into here to fun1, which is not passed by reference, and I print out x, it's still 9, even though I incremented here, because I incremented the value that was created inside memory. Inside memory went out called, which was copied over. So 9 was copied over to a, and then obviously because a is not a reference to x, so nothing has changed. It's just a that has changed, and then it's discarded. But in fun2 right here, I'm passing in x again, but in this case, it's actually being passed in as a reference. So when I increment it here, it's actually changing the x value. So right now, if I print that out, I'm going to get 12, and that is the main essence of pass by reference or pass by value. The formal term for this is pass by value, and here pass by reference. But yeah, so let's get into some objects. Wait, why use auto and training? Oh yeah, actually yeah. So shouldn't int be if you want to return type beforehand? Yeah. So actually in C++, like I forgot which which standard. But yeah, so there's no need to actually include the trailing return type right here. You can just put oh, sorry, I put auto instead of auto, typo here. But yeah, so you can actually not even put the return type right here, because the compiler will know that you're returning an integer, obviously, because a plus b, an integer plus an integer is an integer. There's no need to put int here. And then yes, you said that using together, so using auto and trailing right return type together defeats the purpose of auto. Yes, you're right. It defeats the purpose of auto. And you could say that this would be better. So you could actually put, instead of auto here, instead of putting this here, you can just remove this and put int here. But it's just a style of writing code. And like I said, it's for me a bit more expressive. But again, it's up to preference. So the return type right here and the auto is up to you. It's not more efficient, better, or anything. It's just I view it as more expressive code, but that's it. So it's up to you. So yeah, so let's jump into objects, and then here are some classes. For the people that have done Python has classes, and Java. Here's a quick example of classes in C++. So this is how you write a class. You class sample, and then you need the curly brackets right here. And then inside here, you're going to have public and private. So right here, you can have under public colon, you will have all your public methods and variables. Private, you'll have all your private methods and variables. And this is might be like a too generic example. So here's a quick example as a person. So let's say we're going to declare a person. We're going to have a object that is a person, and inside there. So for the public methods, we're going to have a get age method. So int get age, const. That means that nothing is being changed inside here. So again, like I said, we're telling the compiler that nothing is going to be changed inside this method, and then we're just returning age. And then set age, we're just getting void set age const int age in, and we're setting age is equal to age in. Oh yeah, I didn't go through the variables. So we have stood string name, and we have an integer age inside person. And then right here we're getting the name, so just a getter, you could say. So stood string, that's the return type, get name const, and we're returning the name. And then here void. So oh yeah, one thing that I because I assumed everybody have used Java or C at one point. Void is just, that means that that the function has no return. So there's no returns inside that function. So void set name constant stood string name in, and name is equal to name in. We set name to name in, and that's pretty much it. And then inside here, because the reason why we did all these getters and setters, because stood string name and integer age are private variables that are not being used. So these are same as private methods and private variables inside in Java. And then before actually going into here, so these are the classes. But if you notice here, if you want to, actually, let me go through that right here. So there's something called a constructor in C++. I'm not sure what it's called in Java. I have not done Java at all. Well, I've done it, but I completely forgot everything and don't know their correct terminology. But in Python, in C++, there's something called a constructor. So that's the thing that constructs the objects and sets everything. So you can have multiple constructors, multiple types inside the constructors and everything. Oh, constructor as well. Okay, perfect. But yeah, so you can have multiple constructors in C++. I'm not sure if Java has that. I'm not sure at all. Correct me if I'm wrong, but I don't think it does. Um, but yeah, so we have a class person, and right here, if we have we have the public, and inside public, and this is implicit, a constructor that is called the default constructor, which is just, it doesn't set anything, it doesn't do anything, it just creates that object. Implicitly exists inside a class that does not have a constructor. So the reason our old way of like the previous slide was actually a bad practice to do stood string name and int age without setting anything to it. The reason why it's a bad practice to set to not initialize age or name, because this is implicitly defined here. So that means if I call person right here, then name will have some random strings don't have, so it'll be an empty string, but age will have a random integer in there because we have not set the integer. So in C and C++, if you have not initialized something, it's not set to 0. Most compilers set it to 0. Like actually, almost all compilers set it to 0, but the standard doesn't say that it should be set to 0. Therefore, it's not. It's called undefined behavior. So it's something that you should not do. So it's a bad practice when you have a default when you're not initializing in your when you're not initializing in your constructor what name and ages. You must initialize them using these in these those curly brackets. So that means just name will be empty and then age will just be set to 0. And that's pretty much it. So that's the good practice way to do it if you don't have a constructor here setting what these are. But here's a quick example on a constructor. So I have a class person here, and in public, I have I'm declaring a constructor. So inside that constructor, a person, the parameters, the arguments of the person constructor. So you can have multiple constructors, but this constructor, a constant string that is a reference name in, and a constant integer that is a reference age in. And then in C++, you can actually, like Java, when you have a constructor, you can actually do name is equal to name in, age is equal to age in inside the those curly brackets right here. But it's much faster and much more efficient and much more expressive. And core guidelines recommend you to do so, where you need to use you initialize your class variables as so. So then you have a colon right here, name, and then brackets name in, age in, and this is more optimized way to do it, and the compiler will optimize it for you. And yeah. Other than that, you have person. So person does not exist anymore here. So the one that was implicit exists here because another constructor was defined. So do we still if we still want a default constructor, we could just do person that equals to default, and that will act the same. Will act the exactly same way how we had person implicitly defined here. But yeah, so this was bad. Oh, shouldn't be here. But yeah, so in this case, because I have a constructor and that is the only constructor inside person, that means every time I'm creating a person object, name and age are being initialized. So they're not left uninitialized right here. So then this is also a good practice. This is fine to do because they're always being initialized. If I do auto a is equal to person, this is not valid anymore because there's no default constructor anymore. There's just the following constructor right here. This might be a bit confusing, especially this syntax right here. But for me, it makes sense just because I've been using C++ for a while. So, but if you have any questions, just let me know. So we're just going to go through namespaces. Actually, we're almost done. We're going to be walking through problems soon. So what namespaces are, they prevent name collisions. So if you have functions with the same name, so example stood. So let's say inside the standard, there's max and min. In Python or other languages, let's say there's max and min in C. They're defined as max and min. So what that means is if I make a new variable or a new function called max and min, I'm either overloading the standard function, or I cannot use max and min because they are, for example, reserved. So that's why some people complain about it, but it's actually a very, very good code practice to have namespaces. So that's why every time we in C++ we're using a string, a vector, or anything inside the standard library, we're using stud : So that means it's inside the standard library namespace. But here's a quick example. The reason why I'm going through namespaces really quick is just to understand why it's there in C++, but that's pretty much it. So here's a namespace. I'm going to call that I'm going to write some utilities in there. And that namespace, I'm going to call it util. And inside there, I'm going to just remove all occurrences of a string. And I'm not going to explain too much on what it's doing, but then I have a stud string that is getting passed in as a reference and a substring. And all I'm doing here, which I'll explain a bit later, I'm just erasing every single occurrence of the substring inside a string. And it's called right here. So if I have an auto string, while modern C++ is so nice, and I actually pass the string and a substring in here, so a space inside util colon remove all occurrences, it will become that. So that's one thing. It's just meant, for example, if somebody's using my utilities library, let's say, and then they decide to actually create another function called remove all occurrences, and in that, let's say in C++ there was no namespaces, then if they make remove all occurrences, they are overloading remove all occurrences. So whatever arguments that they have, they're, because you can overload functions. I think that's also possible in Java, with like different types or different arguments or whatever. Yeah, so you're just overloading my function, which causes a lot of name collisions, a lot of problems, and that's one of the problems of C. It doesn't have namespaces, so actually you're going to see a lot of name collisions that happen accidentally in C. So C++ solves it that way using namespaces. But yeah, so that's a quick introduction to why there's namespaces. And then finally, this is actually our last point that I wanted to get to, and just because so we can actually use C++ and actually solve some problems with it. So there's something called iterators. And these iterators, we've discussed them before, but I didn't tell you what they are. This is what connects all the generic containers, generic algorithms, everything inside the standard library together. And it's the glue that glues everything together. And when you actually look into them, they're beautiful. So yeah, so iterators are crucial for connecting standard library algorithms with standard containers. Want to make your own container? Implement iterators. You want to make a container, for example, for the folks here that did 30305, yeah, data structures. If you guys remember the B tree, or the 234 B tree, if you want to implement that and you want to use algorithms on it, you can implement your own iterators for it. But yeah, so if you have a data structure you want to implement, always implement iterators for it. It's very useful, so you can use everything that is provided in C++ for you. So here's a quick example of iterators, and we'll go through syntax really quick before. Like we're gonna go through this, and then we're gonna go through syntax. And then what we have is we have begin. What begin means, begin points to the first element, while end doesn't point to the last element. End means the element after the last element. So 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 just something to note always, that begin is the first element, end is not the last element, it is the element after the last element, so it doesn't exist. So here's a quick example. I have a stud vector of integers, and then that integer, that vector, I'm going to fill it with 1 to 8. And then I do auto it. So people tend to use it for iterator. And the reason why auto here, that's another way to use the reason why to use auto, because iterators types don't look very well, so just use auto. It is equal to vec.begin, and right now it points to the first element in vector, in vec, sorry. So let's say I want to print out it. I need to do references, so I need to put a star, it, and right here I print 1. If I don't have a star here, it's going to print the memory address of where the first element is located, and you do not want that. You want the element itself. And then right here, let's say you want to go to the next element, you do it plus plus, and then you dereference it. So you do star it, and it's going to print out 2. You can also do it minus minus, and then you can do star it, and then you get 1. One thing to note is plus plus and minus minus is only available for specific containers. And I'll explain about that a bit later, because there's some containers in C++ which they can only go forward like a single linked list, and then there's some that can go back and forth like a double linked list, and then there's some that have random access. If they're random access containers, then that means you can have an array that goes back and forth, and it's totally fine. But yeah, so here's a quick example on using iterators. And iterators aren't used in this form. I'm just showing an example. This may look a bit ugly, but we'll see during our leak code examples that we're going to be going through why iterators are a thing. So we have a standard vector in int, and we have vector 1 to 8, the same vector right here. And then we initialized it to vec.begin, and then we're just going to do a while loop. So we're going to print out all the elements of vector. We're going to do while it is not equal to vec.end, because remember, vec.end is the element after the last element inside a vector or inside any container. So then we're just going to print it out one by one, and remember, we need to dereference it to print out the element, not the memory address. And then we're just incrementing it one by one until we reach the end, and then the loop terminates, and we've printed out everything. So that's a quick example of iterators. And then right now, let's solve some leak code. Let me stop sharing my screen and let's hop onto my browser right here. All right, oh, whoops, actually, sorry about that. I have the questions on a slide, so we'll just go through the slides real quick, and then we're gonna do the leak code problem. So we're doing leak code question 977. So we're doing squares of a sorted array. Given an integer array nums stored in non-decreasing order, return an array of the squares of each numbers sorted in non-decreasing order. So what we're practically doing right here is we're just grabbing that that vector, so an array, so a dynamic array, and we're just squaring it pretty much. And let's jump into my browser to solve it. Here's some quick examples, and I actually for that give me 1 second. I wrote some tests here to actually confirm if we're doing it right or wrong. What I'm using right here is Compiler Explorer. I'll actually link it in the resources on the repo. This is this is a godsend. Trust me. It's everything I do in C++ that I want to test. I always test on Compiler Explorer. But yeah, so let's go through actually solving the sorted squares. So what's happening right here is we are we're getting past the nums vector, and then what we need to do first is we need to square each element. And to do so, what we could do is we need to let's start thinking about how we could do it. Okay, we can actually iterate one by one and do a loop, and then multiply each element by itself, and then set that element. But then that wouldn't look too much pretty. Like it would be like a for loop here. So let's write it like I'm writing something like, so we have a for loop. So for I in nums, obviously it's not C++, but I'm showing like an example. I is equal to I times I, right? That's and then obviously C++ can be a bit longer with curly brackets and whatever. That's not really nice. So let's actually do something right here. So in C++, there's something called transform, and what we're doing in transform. So let me go to CPP reference, and like I said, this is your best friend. And a CPP reference, let me zoom in a bit. You have everything here, but then one of the coolest thing right here that I believe is the coolest thing in C++ is the algorithms library. So if I jump into the algorithms library, inside the algorithms library, there's a bunch of algorithms that are all compatible on your standard containers and everything that has iterators, depending on what they support. So what we need to do is we need to transform each of the elements of the arrays and of the vector. And let's actually go through. So what it is, it's called transform. Where is it? Let's see. Transform. So applies a function to a range of elements, storing results in a destination range. So if I open this up, this is all jargon. Don't worry about it. Right here, it's going to tell you how you use it. So first off, you have the first range of elements to transform, the beginning of the second range of elements to transform. So if you want to transform two ranges at the same time, and then a unary operation or a binary operation. So in that case, what we need to do is we need a unary operation which multiplies the element by itself, and then we store it inside the destination range. So we have another destination range, which we give it another, I guess, vector or like another container to store our elements in. And to do so, let's actually use it real quick. So first off, all right. So first off, I have stood transform, And inside std transform, I call it like that, and I need to include the algorithms library, the algorithms header, and I need to include the vector header, and then I have the CSR just to do the tests here, so it's fine. You don't need to include that. I need to include the functional, and I'll tell you why you need to include the functional in a bit. But yeah, so also right here, you can actually see all the examples. Sorry. All the examples on how to use std transform. But yeah, let's go through it real quick. So first off, what we need is we need our beginning range. So our beginning range is actually nums.begin, right? And we use iterators for that. So nums.begin and nums.end. So we are starting with nums.begin and nums.end. And then what we need to do is, because it's asking for another range, so let's say we want to multiply two ranges together, and we're going to just multiply the same range, but we're going to put two ranges. So we need to include, first off, our parameter, the first range, and the first element of the first range, and then the first of the second range, right? So in that case, our second range in that case would be nums dot begin. And we don't need to include the end of that range because we assume that it works. 1 second, am I missing something? No, it's fine. And then what we need to do is, after that, we need to actually give it our, in that case, a binary operation. Our binary operation, I don't expect you to know this right now. We could actually write a lambda right here, like in Java lambdas or lambdas in Python. So we could do, for example, I'll show you two ways to do this. So this is how to write a lambda in C++. And then right here you have the variables that you're catching. So in that case, we have int a, and then actually, you know what? Let's not use a lambda right here. We'll use the functional header. So inside the functional header, let's go with the functional. Functional. Yeah. So inside the functional header, we have something right here inside here that is called multiplies. Where is it? Multiplies. So these are arithmetic operations. What this does, it's a function object implementing x times y. So we're just doing x times y. And then all we do here is we grab this right here, and we can actually open this up, and we could see a possible implementation of it if you want to know how it's implemented. And all we do right here is we just put this function object here, std std multiplies and angle brackets int, and like so. So right here, this is how you actually put like one of these, what do they call them? Those function objects, those arithmetic function objects. And then we end it with a semicolon. Am I missing something here? Oh yeah, nums. So then we actually have that, and what we need to do here is we need to also sort it, because we assume that we're getting a sorted array all the time, but we're not sure. So we can sort it. We can choose to sort it or not to sort it, but we'll sort it anyways, just to show you an example how sort works. So it'd be std sort, and then we have nums dot begin, and then nums dot end. And then to show you an example of how this is implemented, if I go to CPP reference again, and I go to, just give it a bit to load up. So if I go to CPP reference and I go to algorithms, there is sort here somewhere. Let's go right here, sort. And then right here, or all you're doing here is you're giving it the range of the elements to sort and a policy. So oh no, not the policy, the compare. Let's forget about the policy, the comparison, and how you compare the comparison function object. But right now, because it sorts it increasingly by default, so we can just do nums.begin and nums.end. And then all we're doing here is we're returning nums. And we have pretty much solved our first question. So let me double check if I have everything correct here. Std multiplies. Yep, I should be all good. Let me see where the error is happening. Weird. I guess, did I do something wrong here? I think that should be fine. That's weird. Give me 1 second. Let me double check that. Oh, yeah. We forgot one thing here because we actually need another nums.begin. Sorry about that. If we go back to actually transform, inside the documentation here, it says the range of the first elements, the range that you want to transform, the beginning range of the second elements that you want to transform also, and the destination range. We did not give a destination range. The destination range is also nums.begin. And that should work now. And yeah, so all of these tests have passed. So if I comment this out, we're not going to get an error right here. It's going to give us 0. So yeah, so our tests have passed, and this is how you write it. You can also not write a stood sort because we're giving it. Oh, actually no, we're not giving it a sorted array. Sorry. So yeah, so yeah, so that's pretty much it for this question. Let's actually go to the next question. Let me stop sharing, and I'll share my my presentation. All right. So our next question is median of two sorted arrays. Given two sorted arrays, nums1 and nums2 of size m and n, return the median of the two sorted arrays. So what we're doing is what we're doing is just finding the median of those two sorted arrays. There's a lot of ways to approach this, but in my opinion, the best way to approach this and the most expressive way to approach this problem is simply by merging both arrays. And then after we merge both arrays, we find the median because, but we need to merge it while it's being, it needs to be merged, but it needs to be sorted at the same time. So we need to find a standard library algorithm that allows us to do that. So first off, let's actually find a standard library algorithm that allows us to do that. And let's go back to CPP reference. Let's go to, oops, I'm not sharing my screen, my Safari. All right, here. So right now I'm on the algorithms library page on the CPP reference. And all I'm going to be doing is going to just look for an algorithm that does that. In the beginning, you're going to be sitting here and finding the right one. But trust me, it's all they're all under what do you call it? They're all under specific categories, so you can find them easily. But then when you know them, personally, for example, because I've used algorithms a lot, I know that, for example, merge allows me to do that. So there's a merge algorithm, and that merges two sorted arrays into one sorted range. So I give it two sorted arrays, and then it just gives me a sorted range at the end. And then how we use that, if we look at the parameters, we need the range of the first elements, the range of the second elements, and the beginning of the destination range. So to do that, first off, what we need to create a destination range. To create a destination range, all we need to do is we need to create another vector, and that vector is of integers. And let's call that vec. And then you can actually just call that vec and it's all fine. But what it's better to do is, because we know that range, the destination range, is going to equal to the size of num1 plus nums2. What we could do in that case is we could tell that the vector to actually reserve that size for them. So we don't need to resize the vector every time we're adding something. So we do num1 dot size plus nums. Oh, sorry, I put nums1. Oh, sorry. Nums1 dot size plus nums2 dot size, and then we have our vector vec. And then what we do here is we simply just do stood merge. And first off, we need to give it the beginning of the first range. So nums1 begin, nums2, nums1 dot end. And I'll talk about, you might think, okay, this is a bit complicated and might with these all parameters and things like that. I'll discuss a feature of C++ that is being added now. It's in C++ 20, but there's not many compiler implementations of it. I'll discuss it a bit later, so I'll tell you like how it would look, and it would be like a better way to implement it. So we have our first range, and then we need our second range. So nums2 dot end, and then we need our destination range. So our destination range is vec dot begin, and that's pretty much it. So right now we have merged all our both vectors, and now what we need to do is we need to create we need to return the median. So to do this logically is, first off, let's think about this. So the median of the array is always like it's the half of the array at the end. So what we need to do with that array is, first off, we need to check. So if vec.size it's if vec.size modulo 2 is equal to 0. So then that means if it's even, what we need to do in that case is when we return that, we do return, and then in that case, what we need to do is we do vec.at vec.size. To make this a bit more readable, let's do a variable right here, and let's call that size, just because I don't want to write vec.size every single time. But yeah, so we have auto vec.size, and then what we're doing is that not size, sorry, yeah, so at size divide by 2 plus vec.at size not divided by 2, so why did I yeah, not divide by 2 minus is it -1? Yeah, so -1. So what we're doing here is we are finding the middle element and the element after that, and then we're getting the average of them, and that would be the median of the array if it's evenly sized. Otherwise, sorry, just let me just paste this in. I don't know why this is not formatting it correctly. All right, and then otherwise we just return vec dot size divide by 2, and that's it. And then if we run this, our program should return 0. Let's double check that. Yep, our program returns 0. And what we did here is we don't need these brackets right here. But yeah, so our program should return should the test pass now, and this is a way to solve this. We could actually obviously we could write this in one line. So here's a copy. I'll just copy it over. Actually, no, let's not copy it over because there's in Java there's ternary statements. So we have return vec.size. And then we put a question mark here. So if it's even, then we do the following. So we return the following. I'll just copy that over. Otherwise, we return this. So if I remove all of this right here, it should also pass. So you can do both ways. It's totally fine. But just this is a way to do it using ternary statements. But yeah, so that's a quick example of using the algorithms, the containers, and everything in C++. But other than that, I discussed that there's a better way to solve this, but it's not implemented in any of the compilers yet, even though it came out in C++ 20. That's another point that we talked about before, that when a C++ standard is released, it doesn't mean that an implementation comes with it. Implementations are done gradually, like depending on compiler implementers and the standard library implementers. So then there's a better way to actually do this. If we check out merge right here, there, instead of the algorithms library, there's the ranges library. One sec. So in the ranges library, you have, for example, ranges begin. I want to show you guys a quick example of using ranges. Ranges. Where is it? Sort. Is there a sort here? Oh wait, sorry. Oh, sorry, I'm dumb. It's not even in here. It's in the algorithms library. So inside sort, there is ranges sort, where in this case you just pass it v instead of v.begin, v.end. But ranges have not yet been implemented in like today. I'm not sure if Microsoft has implemented it, but I know GCC and Clang have not implemented it yet. But that's an example of using sort instead of doing this whole thing right here. And same thing with, I think there's, so let's go with merge. So there's ranges merge right here, and that's another example of merge using ranges instead of this whole thing right here. But yeah, so the most compilers are and standard libraries are getting them implemented like soon. But yeah, so because the standard was released almost 3 months ago, so they're still implementing a lot of stuff. About that, if you go on CPP reference, like I said, you should bookmark this site like for sure. And one sec, let me refresh the page again. So inside the CPP reference, if you go to compiler support, here will tell you every single feature. It will tell you every single feature and if it's been implemented on which compiler. So I have GCC, you have Clang. So GCC is the GNU compiler, Clang is the Apple not the Apple, but it's like developed by Apple. MSVC is by Microsoft, and Apple Clang is the Mac specific Clang compiler. And here it tells you every single feature of the library, and this is C++ 20 that have been implemented. And you could see, like, for example, C++ 17 features, and here are C++ 23 features. Because features are getting improved during like every single standard meeting, so they get implemented along the way. But that's pretty much it. Let me actually hop back to the slides. But yeah, 1 second. Yeah, 1 second. All right, perfect. So it's a bit laggy, but some people heard most of it. All right, perfect. So let me just play a slideshow in a window. Let me just go to the main slide. Sorry. All right, so let me share my screen. 1 second. All right, so that's pretty much it. This is the first part of the workshop. Let me go to the outline. So this is the first part of the workshop. We covered the what, why, C++, types, variables, containers, control flow. We also went on objects, namespaces, discussed iterators, and solved some problems. Hopefully next time we're going to be discussing a bit more. Let me know. Oh, okay. So is there any advantage between using Clang, LVM, and GCC? What's used in industry more? Does compiler matter for most applications? So at the end, if they all follow the standardization, like the standard, then they're all the same thing at the end. But one thing, different compilers have different optimizations, different ways of optimizing, different hardware and software, like systems that they support. So, for example, LVM is a new revolutionary compiler, you could say. A lot of people do research on LVM and LVM, and LVM has a lot of cool features. If you guys ever want, we could do a workshop on LVM. I wouldn't mind, but I'm not going to get too much deep into LVM. But inside industry, you have modern industry and you have new industry. I mean modern industry and like old industry. In the old industry, most people use GCC and what else? MSVC. But now everybody's using Clang because it has more expressive compiler errors, better errors. It also is, I think, optimization wise, it is better. But yeah, it depends on the person. But again, if you write something in C++, it will compile on GCC, on Clang, and on MSVC, so the Microsoft one, the same thing. It should not matter. So whatever industry you are in, everything should compile except for MSVC, because sometimes the Microsoft one is a bit weird because it's Windows only. But LVM and GCC are pretty much, you can use almost everything. You can compile in GCC and you can compile in LVM, and everything should work. But yeah, so the advantage is just Clang. So LVM is more modern, more research is put into it. Um, um, it's developed by Apple, not developed by Apple. Like the development support is through Apple. But yeah, are there any more questions about C++ or even compilers? Oh, well, questions are like, let's say if somebody wants to ask questions, what I want to discuss is for part two, we're going to be probably discussing a bit more about templates. In the DSC Discord, please let me know and tag me if there's any part of the presentation that you're a bit iffy about or in C++, just let me know. And also just hit me up anytime you want to discuss anything C++. Um, uh, I would love to talk C++. But yeah, so we're going to be discussing next time templates, memory management, constant expressions, so compile time stuff, and then a lot of cool stuff. So tune in for next time. Other than that, I guess we're pretty much done.